Hi everyone, I am Preeti and I'm super excited to be your host for today's session on Introduction to Get Local. Get ready for a practical, insightful, and interactive learning experience. We have an amazing speaker with us today, Mr. Amit Potdar. He is technical lead and in cloud engineering. Amit is a cloud and DevOps engineer with 6+ years of experience in designing, automating, and scaling secure cloud infrastructures for global enterprises. His work bridged software engineering, DevOps, and SRE practices, enabling businesses to innovate faster while staying resilient and compliant. He specialized in building scalable CI/CD pipelines, optimizing deployment workflow, implementing infrastructure as code, and ensuring robust monitoring and reliable across cloud native ecosystem. With hands-on expertise across AWS, Azure, Kubernetes, Docker, Terraform, and Git, Amit brings a strong engineering mindset to modern cloud automation and DevOps strategy. We'll also have a live Q&A at the end of the session, so feel free to drop your questions anytime in the Q&A tab. So, ready to learn, interact, and enjoy today's session. Let's give a warm welcome to Mr. Amit Poddar. Over to you, Amit.
Thank you, Preeti, for the warm welcome and introduction. So, hi everyone. So, good afternoon, good morning, or good evening, based on the time zones. So, welcome to this session on introduction to Git Local. So, over the next couple of hours, we are going to take something that looks scary from outside, like Git branches, commits, head, merge conflicts, and make it simple and intuitive, right? So by the end, I don't just want you to remember commands. I want you to think in Git why we commit, why how Git sees your project internally, and how to stop being afraid of breaking things. So a quick check: how many of you have used Git before? Never, or you have already fought a merge conflict once in a life? You can comment out in chat options. That will be interactive sessions. Uh, Okay, so hello. So as I guess I've recently taken on session based on DevOps CI/CD in the month of November, right? So uh, to be just introduction self, like I'm a cloud and DevOps engineer with over 6 years on hands-on experience in building, automating, and merge managing scalable cloud infrastructure and production systems. So, and I am also a tech blogger and founding member of the Innovative X community. I work closely with AWS, DevOps, SRE practices, focusing on things like infrastructure automation, CI/CD pipelines, containerization, system reliability, and troubleshooting real-world production issues. So, over the years, I have had the opportunity to work on large-scale systems, monitoring. And scalability, and also mentoring teams and bridge the gap between the development and operations, not just by writing code but by designing systems that's stable, secure, and easy to operate. So I strongly believe in learning by doing, understanding that why behind tools, and keeping the things simple, practical, and scalable. So today I'm here to share real world insights, practical examples, and hands on knowledge that you can directly apply in your own work. Uh, so why I'm telling you this? Because everything I share today is from a real project experience. Production systems, or multiple people pushing the codes, or real outages, or real Git mistakes that we had to recover from. So this session is not a bookish; it's a practical Git, that the way we use it in real teams. So I'll bring up my screen, start with my presentation, have access to my screen, right, Preeti?
No, no.
Just a second. Is my screen visible?
Uh, yes, yes. Actually, now it's showing that black. Now it's
Okay. Okay. Screen is visible, right? Hey, Priti, my screen is visible, right?
yes, it is visible, sir.
Okay. Thanks. Yeah. So today's agenda, let me clarify. Like we'll start with source code control basics. What problem we are we even solving, and then we will move into Git itself, how it works internally, the local workflow, init, add, commit, logs, diff, undo commands, and then head. This is mysterious thing everyone mentions, and branching, merging, how teams work safely, and then we'll connect this to GitHub, so you understand local versus remote clearly. So the idea is, the first we will build concepts, then we connect them to real commands, and then we show teams workflow, right? So what is version control system? So let's start with a very simple, basic question. So what is version control system? So version control system is a simply a smart history tracker for your files. It helps you manage files and directories over time, tracks changes, like what changed, who changed it, and when. So it again, like, go back to your any previous state if something breaks. So, and if we say source control, we usually talk about managing source code with such a system. But you can technically version anything: configs, documentation, infrastructure as a code, etc. So right. So imagine writing a college lab report or project kind of thing. You have a v1 final doc, and v1 final new doc, and v1 final latest revised doc. So we'll all get done that, right? So Git is a way of saying, stop doing this manual, I'll track your version properly. So deeper dive, if you have time, like even if you never become a full-time developer, understand version control is like a learning to save properly in a video game kind of thing. You can experiment without fear. Okay. Some history, like Git didn't come first. It's a part of a long evolution. So in, say, 1972, we had SCCS, and then part of Unix, very clearly, very basic, and then RCS, and then CVS in the 80s and 90s. These made collaboration possible, but we had limitations. So in 2000, sub version SVN came, Central Server better than CVS, and then Bitkeeper, a distributed system which inspired Git. So the main thing to notice is early tools are centralized, modern tools like Git and distributed. So what does this matter, right? So because distributed tools give every developer power to work offline, have full copy of history, and then commit locally without depending on the server. So has anyone here used SVN or CVS? You are the wise ancestors of this generation. You can comment out, right? Yeah. Quickly moving to distributed version control. Say this picture explains this difference brilliantly. So on the left, we have the traditional model. A central server holds the main repository. All developers are just clients talking to that one server. Say if the server goes down, everyone is stuck. On the right, the distributed model, where every developer has full copy of the repository, including the history. You can commit locally, experiment locally, and then you can synchronize with others later. So Git is in a distributed category. So that's why open source works so well with Git. Thousands of people can clone, branch, experiment, and then push changes back. So Git was created in 2005 by Linus, the creator of Linux. So he needed a system that could track changes to the Linux kernel with thousands of contributors. Say it's a command line first. All powerful features are available through CLI, and it also ensures data integrity using checksums, SHA hashes, and also distributed, like every clone is a backup kind of thing, and it's a fast cross platform and free and open source. So one beautiful thing about Git is it's designed for a failure. Even if a server dies, as long as one developer has a clone, your history is safe kind of. How do I get Git? Say so installation is simple. Head to git hyphen scm.com. You can download the installer for your OS. Use the default settings if you're new. But remember, Git is not tied to a GUI. Many tools like VS Code, IntelliGI, Git, Kraken, source tree are just front ends to Git. So today I'll focus mainly on CLI, because once you understand that, any GUI will make sense. Coming to repository now, let's talk about very important word, repository or repo. Repository is basically a project holder with a memory. Once you run git initiate inside a folder, Git will start tracking the files and the directories, save the snapshots over time, store it all in a hidden .git directory. So inside a repo, you can have a code files, images, configs, PDFs, docs, data files, anything. So if someone says push the repo to GitHub, they mean push this project folder, including its history, to a remote server kind. Coming to two-tier architecture, that's other VACS. The older version control system used two-layer model. So working directory where you edit files, and then remote repository where committed versions live. So the flow was usual. You edit, you commit directly to the repository. So this means you had less control over which changes go into commit, all or nothing kind. Quickly going through this tree architecture. So working directly, you actually your actual files on disk, you add git edit, and then delete here. And in staging area, also called as index preparation zone, you choose exactly which files hunks you are about to commit. And third is repository, repository permanent history, all your commits with IDs. So the flow is working directly to git, that will have an git add, and then staging area, git commit, and then repository. So this means you can work on multiple things, but git commit them in a clean logical chunks. You can partially stage lines from a file. You can avoid pushing messy WIP commits. So later I'll show you a live how adding something to staging and then committing it, literally just hopping between these boxes, right? So let's do a quick live demo of these concepts become real. We do have commands for here. I can give the PPT to Preeti. Preeti can share it later to them, so that they can go through later when they can have their own practical sessions kind of thing. Or we can do, I'll simply explain with the git commands and then we can do it hands-on session. Is that fine, Preeti?
Yeah, sir, whatever you prefer.
Okay. Or we can ask to audience. I will
Yes, that
one
will be. Yeah,
one.
yeah, yeah. Guys, please do let us know. They are writing anything works. Please explain, then we can have demo.
Okay, okay, fine then. Okay. So a simple Git flow. This is a very basic life cycle of the any project in Git. So it will create a project folder and then run Git initiate. So this tells Git start tracking this folder as a repo and then create a file, say hello.txt file, add some text and stage your changes and then add Git add space dot. The dot means add all current changes in in this folder to the staging area and commit the changes with a message, add hello txt with sample txt, and after that git now has a snapshot of your project state with a unique commit id, author, date and message. And internally git doesn't store diffs like sv and date. It stores snapshots, so each commit is like an entire picture of your project at that time with the smart storage under the hood to avoid duplication. So after initializing a new repo, so the cycle is always like, say, you make changes, files are modified in working directory, you add changes like git add, selected files move to staging, and then you commit changes with the git commit command. Everything in staging becomes part of your history. And a small but powerful point here, right? So say like commit messages, so like bad messages like changes or fix or temps kind of thing. The good messages, you can say that like add login validation for your empty passwords, fix typo in css selector for header title. So good commit messages are a gift to your future self and your teammates, I can say that. Now that we are committing, how do we look back in a time, like say git log, right? So this shows each commit, the author, date, commit message, and that long hash at the top, that's the sha checksum. Git uses these checksums to ensure nothing is silently corrupted. If something changes in a commit that has changes, so git always knows if history has been tampered with. So you can shorten git logs to something more readable like git log hyphen hyphen one line. This shows short hashes plus messages kind of thing. The head pointer, it's like it's a pointer or reference. Think of a head as where I am right now in the history. It usually points to the latest commit of the currently checked out branch. So when you commit, hit head moves to the new commit. When you check out another branch, head moves with it. So importantly, so the head points to a commit in a repository, not to the staging area or working directory. So in this diagram, you see a chain of commits. One on the master branch, the head is pointing to the latest commit. Behind that commit are its parents and their parents, forming a linked history. If you create another branch, say feature X head will move there when you check it out, and new commit will start on that branch. So whenever you feel lost in git, just ask where is head right now. If you know that, half the confusion disappears. So which files changed right? So I just wanted to write this command git status. So it's very important command. Like it answers questions like which files are modified, which ones are staged, are there untracked files, is my branch ahead, behind the remote. So it also visually reflects the three tier model: untracked or modified working directory, and changes to the committed, like that is in staging, and then nothing listed, that is in committed or clean, right? So if you're new to git, seriously, I mean, type git status after almost everything, so it looks it's like your Google Maps kind of thing. Once you know which file changed, the next question is what exactly changed. That's where git diff comes in. By default, git diff compares working directory versus the repository, or versus staging, or depending on state. So some useful variants, like say git diff unstaged changes versus last commit, git diff hyphen staged, that is stage changes versus last commit, and git diff file name that show the diff of for a specific file. So the green lines, that is added, the red lines are removed, so this helps you review your work before committing. That's a great habit, kind of thing. So deleting files, so you can you know if you want to just delete a file manually in your OS, like git only says, oh, my file is missing in git directory, but you tell git, I really want to remove this from version control. So you can use git rm file name, and then this does two things: deletes it from working directory, stages that deletion, and then you commit as usual. So remember, delete with rm, just not via file explorer. uh, Moving renaming files, we use git mv, that is similar to renaming of or moving files. Like say in git mv old name txt to new name txt. So this way git understands this as a rename, not as file deleted here, new file created there. And then internally it will still track you using content similarly. Git mv makes it clear and clean in history. So here some encouragement, like even though git looks huge and more, like say 75% of the time we will be using these commands. If you are comfortable with this, you are already very functional with git. The rest, like rebase, cherry pick, stash, are advanced tools. They are great, but not step one. Undo changes in working directory, git checkout. Like say now let's talk about undoing, everyone's favorite topic, right? So sometimes you edit a file and then realize, oops, so this was a bad idea, I want the old version back. So those changes are only in working directory. Now stage, you can do git checkout file name.txt. This means it take the version of this file from the last commit and overwrite my current one. So this is a destructive for local changes in that file. So only run it when you are sure you don't need those modifications. So whenever we talk about undo in git, we are not really deleting history, we are usually moving pointers or bringing back older versions. Say unstages, like git reset head. What if you staged something by mistake? Maybe you ran git add and it staged too much. To unstage a file but keep it changes in working directory, git reset head file name.txt. Like now the file is still modified in working directory, but it's no longer in the staging area. So you can adjust what will you go into the next commit. Can use this command. So undo last commit, or you can use git commit amend. Sometimes you commit and immediately realize you have forgot a file, or you commit message was bad. Instead of making a new oops commit, you can amend the last one stage, whatever you forgot. Run the git commit amend hyphen m and then better message. So git will replace the last commit with a new one, combine previous content, and then a new stage changes. So this is okay as long as you haven't pushed that commit to others yet. So once you push, changing history needs more care. Amending visually, so this slide shows the concept visually. Like say you are not editing old history randomly, you are just replacing the latest node in the chain. Older commits remain as they are. Let's say 2 months later, you realize, like say getting older versions of a file get check out sha file. So I like the version of this file from the older commit, I want it back. You can do git checkout to the hashes and file name, and with commit id, where that long id is the commit sha. Even a prefix is usually enough. So what happens, like it takes the file name from the old commit, pushes it into your staging area and working directory. So you can then commit that restore older version of X kind of thing. So which files are in a repo? We can list on by git ls tree. So that means it could be a full sha, a branch name, like main, a tag or head. So that will list on a tree hyphen sh, and it list objects like blob equal to file or tree equal to directory. I won't go deep here now, but remember git internally a tree of objects, not just a flat files. Coming to now, we come to one of the best thing about Git, that is branches. A branch is basically a pointer to a line of commits. So why do we use branches? So to try new ideas without breaking main code, or to work independently on features, or to keep production stable while experimenting. So the beauty of branches in Git, they are cheap, just a pointer. You can create them anytime, or if idea fails, delete the branch. If idea works, then merge back to the main branch. So instead of one straight history line, you have multiple streams that can diverge and converge. Branching and merging, right? So a master branch moving forward with commits, and then a branching off another branch created from a specific commit. That branch grows with its own commit. Later we merge it back. So it's like saying, take the changes from this branch and integrate them into that branch. So these diagrams like shows real project with many branches and contributors kind of thing. That no red, tells about the commits, with the tags blue tells about branch heads, and white merges points. So this is how real code base looks, not just a straight line. Understanding branches and merging makes you comfortable working in such environment. Here, sample, I mean, simple commands like git branch. The current branch will highlight with operator, star operator, and you can create a new branch that points you have only created this pointer. And to switch that branch, the shortcut is git checkout feature or login page or something like that. And to switch um, new branch, and you are like say your working directory should be clean, no uncommitted changes that could be lost. So to have a specific command, you can use that. Comparing To compare two branches, like say git diff first branch and then second branch, this helps you see what changed between them. To merge, check out the branch you want to merge into, like for example git check out main, and then merge feature branch in. So git merge feature, say an example like login page. So git will combine the history, either do a simple fast forward, or there is a divergence, create a merge commit, or ask for conflict resolution. There are two main merge scenarios, like fast forward merge. If main hasn't moved since you branched, git just moves main pointer forward. No extra merge commits history. That is still linear. So second thing is recursive. That's a three-way merge. Both main and feature branch have new commits. Git needs to combine both histories, so it finds a common ancestors and perform a three-way merge. So you end up with merge conflict that has two parents. Knowing this helps you understand why your history sometimes looks like a straight line and sometimes like a branching tree. The famous merge conflicts, right? So merge conflicts happens when the same part of a file was changed two branches. Git doesn't know which version to keep. For example, on the slide, the master branch says an apple, and a new branch, same line now says a banana, right? So git cannot guess whether you want apple or banana, so it stops and asks, hey human, please decide, right? To resolving this merge conflicts, git marks the conflicting section inside the file, uh, this kind of thing. And these are the markers, and your job is to edit the file, choose or combine content, and then stash and commit. uh, you have three options about the merge, that using git merge about. You go back to the state before merge, and then fix manually, open file, edit until logic is correct, remove conflict markers, and git add and git commit. So, and the third will be use merge tools, like say tools like VS Code can built in merge, and then meld, beyond compare, etc., right? So that's important, like to have conflicts are not git being angry at you. It's git protecting your code and asking you to choose consciously. uh, yeah, to see say graphing merge history, that visually we can see that, like say a commit graph, you can run git log hyphen graph, one line, all decorate. So so the hyphen graph, that is isci tree, and then the command hyphen one line, that tells about short format, and hyphen all, that tells about all the branches, and hyphen decorate, that's a branch or the tag names. Also, to reduce this merge pain, right? Merge often don't wait for weeks, like keep commit small and focused, regularly bring changes from main into your feature branch. Can call this as a tracking or rebasing. Now let's connect local git and remote github repository. And one left side, like say in the diagram, we have everything on your machine, working directory, staging area, local repository. On the right side, you have the remote repository, uh, git github. uh, you can clone, you do your local, like edit or add commits, you push your commits to the remote, others pull or fetch these changes. And in the terms, like say in origin is in the default remote name, and origin like origin slash master represent the remote tracking branch. So in the team flows, we add folks, and then pull request. But the base is always local git plus remote git talking over push or pull. Can just smoothly transition here, right? So this is basically reinforcing that relationship between your local repository and remote repository. Think is that's an think it is a like a synchronization of histories between multiple people. To start, like can say work in an existing project, you can clone git clone and download the repositories and set the origins to that url, checks out the default branches. You can usually have main or master. From that point you already have a complete history branches and the files, ready to create new branches, modify, commit and push. Yeah. So this is all about the presentation, and coming back to demo, we can have the demo session, right? Or we can have questions. I can take that also.
First, let's like give a small demo, then we'll take questions.
Okay. One time setup, guys. Like say, we'll see. These are the command. Like say version. If you have a Git, have a Git version like 2.3.9. So just wanted to confirm Git is installed and which version is I'm running. So this prints your Git version, which is helpful because some commands differ slightly across the version. And then next is git config hyphen global dot name. Now I'll configure my name so Git can store it in every commit as the author. So what does it do? Like say it writes this into your local config. So every repo on this machine will use it unless overridden. So next is git config global user dot email. So I'll set my email so commits are correctly attributed. So Git attaches this mail to commit metadata, and like GitHub uses this to link commits to your profile. Okay, let's say now git config hyphen global L. So with this command list my global git settings. So you see what's stored, and also this prints your global git configuration like name, email, default editor, etc. Right, can see username, user email address and credential to self. Now we'll create a folder, say git local lab sorry, and right. Okay, I mean SRE, SRC. Okay, so I'm creating a project folder and a SRC directory, the source directory. just like a real repo structure. So hyphen p creates a parent folders if needed, and cd moves into the project directory. Okay, now I'm in src. We'll write git initiate. So now to convert this normal folder into git repository, we have to run this command. Like that, git creates a hidden git folder where it stores all history, commits, branches, and metadata. Okay, and let's say minus a, can see git that shows .git folder. Um, let now create a files echo. um, let's say git local demo lab it. This will add to readme file. So it creates a readme because almost every real project starts with one, right? So that will write in content into readme. So this is still only in working directory. Git hasn't tracked it yet. Now again one more file I'll create. Let's say echo version one initial scope to sra app.txt. So now I'll add app specification file inside this SRE. So it creates a tracked candidate file with the initial content in working directory only. Okay. Next, and I simply have a config file because configs are commonly version 2, right? So we'll create a config.txt file, env, that is dv sre slash config txt, right? Now we'll see. I'll run git status. So this command you can run 50 times a day when learning git. But yeah, it tells you what's untracked, what's modified, what's staged, and whether your working tree is clean. So as you can see that untracked files, that is readme and sre folder. So now I'm staging only README. The first to show that staging lets you choose what goes into commit, and then what it does, like say, moves README from working directory into the staging area, that's in index for the next commit. Can have a git add readme dot md, right? And let's say git status. So watch git status now. Readme is staged, but other files are still untracked. That confirms no staged versus unstaged separation, which is git tree workflow from the slides I just mentioned, right? So the git status tells about the changes to committed and tracked files. Now git commit hyphen m. Now create a that now I'm creating a snapshot commit, and I'm describing it with a message. So it creates a first commit object storing a snapshot of stage content and moving head to that commit. Add readme, right? Now, so I'll stage the remaining files using git add command. So that dot means currently directory direct changes. So adds all new modified files to the staging area. Again, git status. Now we can see all the files are changes to be committed, right? So you can see all the files are under changes to be committed. That confirm staging is full and ready to commit. So now I'll do one thing. I'll run a command git commit hyphen m and add initial app spec and config. So this commit captures our initial spec and configuration in one clean unit. So that records a new commit on top of readme commit. So representing the project's initial baseline, right? Can see after that we can view history and understand what the head command git log, right? So now git log shows the full history commits, author date, and the sh hashes. That also shows commits in reverse chronological order. So head points to the latest commit of the current branch using this command git log. And if you want to have one line, you can use git log hyphen hyphen one line. Sorry, git log hyphen hyphen line. Yeah. So I prefer hyphen one line during live demos because it's readable and fast. So that shows a compact history, short sh and the commit message, right? So say if I make real changes like inspect with a diff, can run echo. Let me clear the screen. Echo and then feature login sorry app txt, right? So now I'm adding this feature line. This simulates like real development progress. So now appends a new line in a working directory. So git sees a file as modified, right? Git status, this is modified, right? So like say now we have now we can show sorry app.txt has modified but not staged. So confirms that change exists only in working directory, right? So if I run a command give diff, that shows changed line say line by line before staging. So you don't commit surprises. You like compares working directory versus latest committed version. Now I'll add git add src app.txt. I stage only this file because I want commits to be focused and clean, and places only src app.txt changes into staging. So this commands helps us to do that. And after that, I'll run git diff um, staged. That shows exactly what will go into next commit, and compare staging area versus the latest commit. Sorry, git diff, right?
Amit,
Okay.
I'm so sorry I'm disturbing you in between. Actually, we have one session feedback form, and I just need like a 1 minute so like people can fill it.
Yeah, sure. Go ahead. Go ahead.
Yeah, and side by side we can show the demo, guys. Session feedback form is like I have launched. You'll be able to see it on your screen. Please rate it. It will not take more than 10 seconds. So please, it is very helpful for us.
Okay. Where were we?
Please,
Git.
your suggestion is very important.
Where were we? Okay. Git diff staged, right? Okay. Next, I'll run this command. So this no, I wanted to commit small and descriptive. So this is what makes Git's history useful, right? So git commit -m, then add login kind of feature to spec. One file changed, right? So next process flow is like I just wanted you guys to know about the undo workflows, like local safety kind of thing. And to run this command, we can have an echo. Then I say I'll mention as a temporary, like debugging for a debugging note. Uh, src app.txt. So this simulates like say and mistake a temporary debug line. I don't want, so adds lines to working directory only. uh, and yeah, let's check out now. Let's say git checkout hyphen src app, sorry. Right, so this restores the file from the latest commit, wiping my local uncommitted changes. And also, what this is like, say, resets working copy of that file to match head. So this is destructive for uncommitted edits, right? So now if you want modern working in especially I can say, you can have a git restore source app.txt is the newer equivalent, like say git restore src app.txt. Now we will have an undo staging reset head, right? So we'll run this command echo feature logout, right? So now I added logout, and then I'll stage it, and then I'll show how it unstage it. um, that modifies file in working directory. And let's say run git status, all the files changed, this is modified. Okay. I'll add this file, this rc app.txt file. I stage it so Git is ready to commit it. This moves change to staging. Okay. Next is Git reset head. Um, uh, if I realize I'm not ready, like say and Git reset head file removes it from staging but keeps the actual change. So like unstages file without losing content, file stays modified in working directory. Can use this command. This rc app.txt file, right? Lastly, the fix latest commit, that is amend. We can use it. Like say git add src app.txt file and git commit -m add logout feature. Okay, so that now it will create a new commit that head moves forward with a commit message. Now we will see renaming and deleting uh, the files. Say I will have this git mv sorry see config txt and then source directory config. Uh, oh, okay, that's it. Oh shit. Moving the source to config.txt to config dev.txt. I'm just renaming the config file to be more specific, guys. Here, like git mv handles rename plus staging in one step. That renames the file and stages the rename so git records it cleanly, right? Can check in the src. Earlier it was a config.txt, now it is config.txt file, right? So next is git commit uh, with the message rename config config dev. -m, right? So that records rename in the history. I can see that. And after that, we can remove the command as I have early mentioned, removing src config dev.txt file. I guess we have already removed earlier. It's the same file, right? Okay. Now we'll commit change config from repo. Nothing to commit. Okay. Next command is git branch. So this shows what branch I'm currently on and which branches exist locally. It also lists branches, and star indicates like say current branch. And coming to git branch feature like UI kind of thing. So that is like I create a new branch for UI work. Now branching is basically creating a new pointer that pointing to a current commit and doesn't switch it, right? So then we can check out feature UI, switching to a feature UI. So all new commits go to this branch, moves head to that branch and updates working directory accordingly. So this is the command git checkout feature. You can have any branch name though. Okay. Um, Next is, so I'll add a no requirement and say I'll add a new UI requirement line on this feature branch. Just make changes to the command echo UI login page layout is see app.txt. No, in the directory now. Now git checkout master. Oh, sorry, I haven't added a git add source app.txt. What is this? Git status. Oh, git status on branch, right? Correct only. Echo hyphen UI, and then login page layout changes. Source app.txt file. No CHP. Okay, so this error is not a Git error. So this is coming from the shell JS itself. So the file path say src doesn't exit from the current location. So either the sre folder doesn't exist or the app, but I'm not inside the correct folder. I guess pwd on the current folder. Right. Okay. Then git checkout master added. So this error says like say path space master did not match the file, right? So this doesn't mean Git is broken. It means like Git doesn't not have a branch named master in the repository kind of. Can be of main. Modern Git version may have a main and instead of master. Can first check out to master. Okay, main we have, right. um, Git checkout to main, switching to main branch. So this is a primary branch here, so we need to switch to main and not to the master. And so why we see, right, we usually get this kind of error like say path specification, like it's a gets internally word or for something like I'm trying to reference. So it could be a file or branch or tag or a commit. So the thing you type doesn't exist in git knowledge kind of thing, right. Um So yeah, I've covered almost all the commands over here. Uh, Please let me know if I wanted to uh, tell more about any commands so that I can take it up.
Actually, Amit, we have like few questions, so I think we can take two or three questions.
Okay, sure.
Yeah, yeah. First one is what is difference between a branch and feature branch?
Just a second, 1 second. My screen is visible, also.
Yes, screen is visible.
Yeah, go ahead, Priti. Yeah.
Yeah, if you want, like you can also stop like sharing the screen also, like it's totally your choice.
No worries, no worries. Yeah, I can hear.
Okay, okay, okay. So first question, Mr. Rama is asking, what is difference between branch and feature branch?
Okay. So So it's a like say it's a very good question. So actually, a feature branch is not something different from the branch. Um, did I mention feature branch over here? Yeah, kind of thing. Yes. Okay. So a feature branch is a type of a branch. It's like more about how we use it, not a different Git concept. Let me explain simply. Like say in a Git, a branch is just a pointer to a series of commits. By default we have a main branch. Now we like say now we in the latest version we call it the main branch. Like it's like an main or a master. So any branch you create is technically the same on thing under the hood, right? So now we now where does a feature branch comes in? Like say a branch created specifically to work on one feature, one task, or one change in an isolation, we can use a feature branch. Branch is a generic git concept, whereas feature branch can have a purpose based branch, can say.
Yeah. Okay, so thank you. Another question, Devadeep is asking, what is the difference between Git and GitHub?
uh, yeah, I haven't covered GitHub, right? Yeah, yes. So GitHub is as a platform, guys. Like say, this is usually the confusion in very common. Let me clarify it in a very simple way. Git and GitHub are not the same thing. They solve different problems. Git is a tool. It is a version controlled system that runs on your local machine. Like say with Git, you can track changes in your code, create commits, create branches, merge code, go back to previous version. And then the important part is like it works completely offline. You don't need internet or you don't need GitHub. As we saw, right, we haven't we didn't have any internet facility. Just we ran the commands in a local repository, and we created repository, and we did the commands, right? So it's all about like if you have installed Git, you can manage your code history locally. And coming to Git Hub is as a platform, as I mentioned earlier. It's a cloud service that hosts Git repository, helps you to store code online and share code with others, colleagues, collaborate with the teams, review code using pull requests or manage issues or like CI/CD actions, permissions. So they were a place where a Git repository live on the internet.
Okay, sir. Thank you. And I'm so sorry, guys, due to time constraint, like we cannot take much questions. You can like reach out to him directly. His we have like we will share his LinkedIn ID. Is it fine, right, sir?
Yeah, sure.
Yeah.
Whatever I've
So
explained in this session is very simple, guys. Like say it's a simple commands. We do they use these common commands, but more than that, we do have commands like say git, rebase, conflicts, merges, conflicts. So those are very critical. So whenever that is possible to use it, like say we can yeah.
okay, ठीक है. Thank you so much, sir. Thank you so much for this session. We truly appreciate you taking your time to share your expertise with us. It's an absolute pleasure to having you. And thank you so much to people who joined us today. We hope like you enjoyed the session and took away some valuable insight. And if you'd like to revisit the session or share it with your peers, the full recordings are available on our LinkedIn page and YouTube channel. So until next time, like stay curious, keep exploring, and never stop learning. Wishing you all wonderful and happy weekend. See you soon. Thank you so much, sir, once again.
Thank you,
Thank
Preeti.
you. Thank you. Bye bye.